Hi everybody, Aaron from Solace here. Today I'm at a Fix conference in Singapore talking about trading platforms with crypto exchanges and financial services companies. Anyway, today's video is all about KEDA, the Kubernetes event-driven autoscaler. I'm going to show you how to install the Solace scaler in your Kubernetes environment so you can scale up and down your Solace event-driven microservices all automagically. So let's check it out.
Check it out.
Okay, so if you haven't heard of KEDA and you're using or are interested in Kubernetes, then head over to keda.sh and check out all the information they have there. Click on Concepts and give this a read. KEDA is a lightweight Kubernetes resource that allows you to scale your workloads, your apps, your pods, your containers up or down based on metrics. Metrics such as number of messages per second, number of requests per minute, number of transactions per second. These are the events in event-driven autoscaler. I really think it should be called the metrics-driven autoscaler, but yeah, I guess KEDA doesn't really roll off the tongue. Now, this doesn't replace the horizontal pod autoscaler. It works with it. It just makes it smarter. And how does KEDA know when to scale your apps up or down? Well, that's based on these scalers. Scalers are custom resources defined for a wide variety of infrastructure, backend, databases, message brokers, event brokers such as Solace PubSub Plus. Now, the Solace scaler is made for guaranteed consumer applications, and as such, the scaler pulls the broker for SEMP, using SEMP to look at queue metrics. Metrics such as ingress message rate, number of messages spooled on the queue, bytes on the queue, and you configure thresholds that say per consumer, this is the maximum rate or maximum number of messages that should be per consumer, and the autoscaler will scale up or down based on those metrics. Metrics, yeah. Anyway, I'm not going to go through all the configuration options. Just Google Solace KEDA, and I'm sure you'll find this page. I just want to show it to you working in real time. So for this, I'm going to use my Partitioned Queue demo that I wrote in the summer, github.com/Solace Labs, search for PQ demo. Big shout out to my colleague Dennis, who is instrumental in getting the Solace scaler into KEDA. He helped me get set up with KEDA with Kubernetes and getting this all running. So I'll put a link to his demo down in the description, and I stole this picture from him. There's his demo, but I took his configuration and I applied it to my Partitioned Queue demo to give it a nice visual feel. So you can run this as well in your Kubernetes environment. To do this, you're going to need these YAML files. These are CRDs, custom resource definitions, and these specify the consumer application, which I had to make into a Docker container, some CPU and memory limits, secrets for the subscriber, which queue to connect to, username, password, a broker secrets file that's the SEMP username and password for the scaler to query for those metrics, and the Solace scaler. Now, this is just an example. You can configure this however you want. You can see here that I have a polling interval of 5. I can scale down to 1 consumer. I can scale all the way up to 12 consumers because I have a 12 partition queue. I can scale up 4 pods at a time, scale up, scale down 2 pods at a time. And these are the thresholds, the triggers by which this autoscaler knows whether to go up or down. So per consumer, I should be doing about 90 messages a second max, or have about 1,000 messages spooled on the queue. And if it's more than that, then the autoscaler should scale it up. So, all right, let's go. I already have the demo set up here and running. Let's go full screen. My publisher is sitting here paused. My order checker is running. If you haven't seen this demo before, I'll put a link somewhere up here across my face. I did a video all about it. I'm not going to go into details, but yeah, let's just get it going. Let's inject the subscriber configuration into Kubernetes, which will configure, connect, and deploy one of the, and let's unpause the publisher and start it going. Now you can see here that my publisher is configured with 10,000 keys. My order checker ordering is looking at sequences, so the order checker is working. And you can see that my subscriber here has a slow subscriber delay of 10 milliseconds, which will give it about 100 messages per second throughput, which is related to that 90 messages per second I can have configured in the threshold. So let's go ahead and crank up the message rates even more, 500 messages a second, so we can start to see the KEDA autoscaler in action. Now, immediately you can see those partitions start to fill up. Our poor subscriber here is overloaded, only able to do about 100 messages per second, while the ingress message rate is 500. So in just a little bit, I'm sure the autoscaler is going to say, hey, the rates are too high, the queues, these partitions are too deep. We're going to have to add more pods. Now, if you don't have a nice GUI display for your application, there is this command line kubectl get deployments -w you can just run, and Kubernetes will just echo to the terminal the apps, the pods, as it scales them up or down. So give it a second. I'm sure we're going to see Kubernetes add up to 4 pods at once as part of dealing with this big burst of messages that we have. There it is. 4 more pods added, all connected to the queue. The queue is going into that rebalance delay. And then there should be a max handoff as those partitions are reassigned from that poor, slow guy. There we go, 5 seconds for each. And now we have 5 consumers joined, able to do about 500 messages per second. So right now we're about even, messages in, messages out, but the queue is pretty deep, 22,000 messages sitting on that queue. The autoscaler is probably going to add another couple of subscribers to deal with that backlog. So, and through the magic of time compression, let's just fast forward to when that happens. There we go, another 4 subscribers added. Let's zoom out here a little bit. There they are. Again, it's going to connect to the queue, initiate that rebalance delay. At the end of that, it's going to reassign. There's going to be that max handoff timer as partitions are reassigned. The max handoff timer allows applications that, partitions that are getting moved away from them to finish acknowledging messages back to the queue, back to the partition, so that those messages don't have to be redelivered to the next consumer. And as you can see, the order checker that's sitting here listening to all this data did not see any redeliveries, did not see any duplicates, because these partitions are being handed over gracefully. There is enough time for these applications to acknowledge. So no gaps in sequencing, no redeliveries, nothing, no problems. So now that we have 9 consumers sitting here running, able to do, looks like about 800 messages a second, plus or minus, these consumers, these partitions should really start to drain out. Some of them are really draining quite quickly, you can see there. But will they drain out fast enough? Nope. We're going to scale up to the full 12. Look at this. The autoscaler is going to add another 3. There we go. We're at our full 12 number of consumers. Again, you can scale, you can configure all of this, based on, you can make it more aggressive. You could scale 6 up at a time, or you could have a longer delay between how long it scales up. So maybe give it time to work through that big burst. Obviously, every time we add or remove consumers, there is a rebalance, and that can cause some issues with regards to, keys getting flipped over to somebody else. So things to keep in mind, maybe don't rebalance as often as you can, but just for this demo, I just wanted to show how dynamic it can be. So there we go. Our consumers are able to drain all those queues. The autoscaler is going to start to scale things down here in just a second. There we go. We're going to remove 2. Now, when Kubernetes decides to scale something down, it sends a SIG term to that application. And in Java, that means you need to basically have a shutdown hook to capture that signal. Rather than just exit the main thread, it allows the app to essentially say, oh, someone's going to be shutting me down. I can stop my flow, my queue. I can finish acknowledging the messages that I have internally. And so when I shut down and my partition gets reassigned, I've gracefully acknowledged every message and I've flushed everything to my backend database or however it is, nice and gracefully. Now that's gracefully. What happens if we kill an app? This is Kubernetes. It's watching all these pods. If I go in there and just send a kill message, Kubernetes should replace this guy right away. Boom, yep, there's a replacement and gets reassigned to his partition. You get a few duplicates there. The order checker gets some duplicates because, of course, because we killed it, it was a hard kill. Any messages that it had outstanding have to get redelivered to the new consumers. Again, the autoscaler is scaling down. Let's go ahead and actually turn this off now. We can watch this sitting here, and the autoscaler will essentially shut down all these pods now that our message rates our big message spike is over. Anyway, that's the whole demo. I hope you enjoyed it. If you did, leave a like. Come and find me on solace.community. If you have questions, you want to see this thing in action, ask more questions about it. Again, it's on GitHub under Solace Labs. Hope you enjoyed it. Thanks a lot for watching, and see you in the next one, all right? Bye-bye.